Well, we have question 5.3 here that says in the diagram below, T is a point in the third quadrant. We can see the point T here in the third quadrant. That's the first, no, that's the first quadrant, second, third, and that's fourth. So the third quadrant is here where T is. And it is given that sin of alpha is equal to P over square root of 1 plus P squared. Now, question 5.3.1 says show that x equal to -1. Okay, when they say show that, it means x is already -1, but we need to prove it, prove why it is -1. Now, I want to write here question 5.1 here is when we need to prove that x is equal to -1. Now, I prefer to do the same graph here, okay, where I'm working out 5.1. Let me just make it a bit bigger. Okay, so let's see the graph first. When we see the point C here, that it has coordinates, okay, x and p coordinates. It means that as we can see there, its x coordinate is it's x here, and then y coordinate is p. So it means also the distance from the origin to where x is oh, this is equal to x, okay, and it is equivalent to this one, to over here also all this distance. And now also p, it means the distance from the origin to p, all this is also p. So I prefer to do it over here. All this is p. Now we have something like a triangle here. Something like that, okay? Maybe it's not okay, we have a triangle there, a right angle triangle there. Now we know the value of xp. No, we don't know the value of xp, x or p yet. So all we do know that in the equation, it is said that sin of alpha is equal to p over square root of 1 plus p squared. So we need to prove that. What do we know? Our angle is there. This side is called opposite to the angle because it is opposite to the angle. And then we can use sine of the angle. We do know that sine of the angle in tricks. Sine of the angle theta is always equal to opposite over hypotenuse, h over h. And we can work it out. We do know O is given, it's P. So it's P, I'm writing P here. O is opposite to the angle is P. So this is P. And then over hypotenuse is what we do not know yet. But hypotenuse is what I prefer to put here. H squared is equal to opposite squared plus adjacent squared. Okay. Adjacent is to the angle. Adjacent is this side. It is adjacent to that angle, and P is opposite to that angle. Now we can work it out by saying that H squared will be opposite, which is P squared, plus adjacent, which is X squared, and then H will be equal to square root of I can just X squared plus P squared. Okay, so this is the square root of x squared plus p squared. Now here, because we work out sine of the, this is sine of the angle theta also, sine of angle alpha. Okay, we will then equate the two angles. So we have like the two values. So we have like p over square root of x squared plus p squared equal to p over square root of 1 plus p squared. Now, this implies that because they're all both value of sine alpha, okay? Okay, because this angle alpha here, this is 180 plus something can be reduced to this is like 180 plus something. This can be reduced to alpha. So we have something like this. So the two are equal, and then this means x squared here. X squared here is just equal to 1. Okay. So this implies that x squared equal to 1. Now we need to work out the value of x. What can we do? I want to do x squared equal 1. So what we do, we square root both sides. Okay, we square root there, and then at the moment that we square root, I want to do this. At the moment that we square root, we need to remember that this will be x squared equal to plus or minus 1. Always put plus or minus 1 when you square root an equation. Now this means not x squared, but x equal to plus or minus. And then this has two solutions. It's x is equal to positive 1 or x equal to negative 1. Now we can see where the point T is. T is on the third quadrant. On the third quadrant is negative because it is on the left-hand side of 0. So we cannot take x is equal to 1. So we say x equal to negative 1. Thank you. Now, the following question says, write cos of 180 degrees plus alpha in terms of P in its simplest form. All right, I'm going to move this way and then we split my board. So we have like 5.2. The question says cos of 180 degrees plus alpha plus alpha in terms of P. Okay, in terms of P. Or in terms of P, I'll abbreviate it like that. P. Okay. I'm going to paste the same graph over here also. We need to work it out with the help of this graph. So let me make it a bit bigger. Okay. First, what do we know? Cos of, okay, I'm going to draw the circle here. If I draw my trig circle here, let's say it's that one, and then we do know that cos is positive on the first and the fourth quadrant, so it's negative here on the second and third. Now, when we have cos of 180 degrees plus alpha, this means we are on the third quadrant, okay, where cos is negative. So this can be reduced to negative cos alpha, okay. So because we are on the third quadrant here, here is cos of 180 degrees plus alpha. So its value will be reduced to negative cos of alpha. Now, how can we work out this? Now, let's first work out cos of alpha. Okay, we have our angle, our triangle over here. This is x and this is p. And with this one, we found it earlier. It was x squared plus p, but we do know the value of x already is 1. So I'm going to write 1 plus p squared. Right. In the previous question, we worked out this was 1 plus p squared. Now we're going to work out cos now. What do we know about cos? Cos of theta is equivalent to adjacent over hypotenuse. This is the formula. So adjacent side is here 1, and hypotenuse is that. So this can be reduced by saying that makes negative adjacent is 1 over hypotenuse is 1 plus p squared from the root. So that's, we can just remove the bracket. That makes square root of 1 plus p squared all under 1. Okay.